Good morning, everyone. I'm so excited to start our second week of science. Today we are going to be looking at bridges. Bridges are really important because they help us cross rivers, streams, canyons, and other roads. So the people who build bridges are called engineers, and they have to think about what type of material they need to use, what type of traffic is going to be going over top, and how long they have to build it. So if it's just people that are going to be going over top of the bridge, they don't need to use material as strong as if cars or trains are going to go over top. So we're going to start our scientific method. So my question is, we are going to be seeing which material out of aluminum foil, wax paper, cardstock, or regular paper are going to hold the most amount of loonies. So after our question, we then go into our research. So we could research which materials are strongest, and from there, you make your hypothesis. So for your hypothesis, it's an educated guess, and you decide which material you think is going to hold the most amount of loonies. Next, we design our experiment. So we have all the materials, all of our different papers and our loonies and some tape and our books that are 10 inches apart. After that, we do our observations. So from there, we count how many loonies each material holds. And finally, we do our conclusion to see if our hypothesis is correct. All right, so let's get into this experiment. So we have our two books that are high enough to keep our bridges up. We have the spacing that's 10 inches apart. We have our money. We have our tape. And we have our paper. So first I'm going to put the paper across the two books and see how well it holds. It doesn't hold very well. Next, I'm going to try folding it in half. And we're going to see how well that stays up on those two books. Well, it holds better than the paper flat. Let's see if it'll hold the dime. It kind of falls off and sinks down. So that's not a very good structure for a bridge. Now we are going to make what's called a trench bridge to hold all of our coins. So you fold it. And fold it again. So basically I've taken it from the paper, we folded it in half, and then we fold it in half again, and then we're doing it in thirds to make a trench in the center like that. Next, I need 2 pieces of tape to tape this side to hold it together, because otherwise it comes apart like that. And we want it to be a little bit firm. So I'm going to put some tape here and some tape here. Well, let's start with the paper one. So we're going to put this here, and I'm going to start with loonies, and we're going to see how many it holds. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it holds 11 loonies before they tip over and fall out. Next, we're going to pick all these up and we're going to try a different material. So to save time, I already made this one. This one's made out of wax paper. It's hard to see because it's in the light, but we made it the same way with 2 pieces of tape and folded into a trench bridge. So now I'm going to start. We're going to do 1. Oop. Maybe we'll see if that, we'll try it again. See if that was just a 1, 2. So it held 2 loonies. All right, now we are going to try our aluminum foil, which is also hard to see because in the light it gets a little shiny. So let's try this one. 1, 2, 3, 4, 5, 6, 7. Oh, that one's a bit stronger than the wax paper. All right, and lastly, we're going to do our cardstock, which has 2 pieces of tape like all the rest of them. Ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, that just fell out because it's full, 43, 44, 45, 46, 47, 48, 49, 50. I've run out of coins, but I think we know the clear winner of the strongest material for this bridge, the trench bridge. All right. Now we are going to talk a little bit about bridges. So there are 6 main types of bridges. So this is a beam bridge. This bridge is the simplest to build and was often used in historical times because it was so easy to build. So it has 1 or more horizontal beams, so that's along the top this way, that span an area between abutments. So those are these. Those are called abutments, or relieve some of the pressure on structural piers. So there's structural piers. The core force that impacts a beam bridge is the transformation of vertical force and flexural load that is transferred to the support structures. So the force up here, so all the weight that's up here is transferred to all of these structures down here, the support beams. So this next bridge is called an arch bridge. And so the arch is the main structural component of this bridge. So this little moon shape down here, which is always located below the bridge and never above it. The core component of the arch bridge is the abutments and pillars. So abutments and pillars, which carries the weight and force of the entire bridge structure. This next bridge is called a cantilever bridge. So it's a similar appearance as the arch bridge. However, they support their load not via the vertical braces, but by these diagonal bracings and horizontal beams that are supported on one end only. So this is called a suspension bridge, and it uses ropes and cables spreading from the vertical suspenders to hold the weight of the bridge in traffic. So you have the cables that are along here with vertical suspenders. So this is the Golden Gate Bridge, which is an example of a suspension bridge. And this bridge is called a truss bridge. So it uses they call it a diagonal mesh. So they use triangular posts. So if you see those look like triangles above the bridge to distribute the force from the cars or trains down below, and it almost across the entire bridge structure. So this is now fun facts about different types of bridges. So this bridge is the longest bridge in the world. It's called Danyang Kunshan Grand Bridge, and it is located on the Beijing-Shanghai high-speed railway in China. It is over 164.8 kilometers long. So it's all here and over there and goes this way. It's quite long. And this bridge is the world's tallest bridge. It is called the Millau Viaduct, and it's over 343 meters high. The bridge goes over the River Tarn, which is located in southern France. I also like how it has all these suspension cables hanging from them. It looks really pretty. So this is the largest arch bridge in the world, and it is the Kaohsiung Bridge, which is located in southwest China. It is 1,741 meters long. From here to here, it's really long. And finally, we are at the oldest bridge in the world. This bridge is called the Arkadyko Bridge, also known as the Kazarma Bridge, and it is located in Greece. It is believed to be the oldest existing bridge in the world. It was built around 3,300 years ago. And it's an arch bridge. Thank you so much for learning a little bit about bridges with me. I hope you have fun. And if you'd like to try doing this at your home, there's a couple ways that you can do it. You can find your own materials and make your trench bridges, so you can try different materials, or you can use paper and try different shapes of bridges and see which one works best. I hope you have fun. Thank you so much for doing this with me. And tomorrow I'm going to be making a rainbow. Bye everyone!